Hello students. So in this new series of organic chemistry, I am going to cover a topic of organic photochemistry. So various topics under this organic photochemistry are like introduction of organic chemistry. You will get very deep introduction, each and every step explained very well. At least 3 lectures are only on introduction. Then the reactions of N pi star. Then we will learn the base of photochemical reactions. And after that we will discuss the Notch type 1, that is alpha cleavage reactions, with a lot of examples. And after that we will discuss the Notch type 2 reactions, again with lot of examples. Each and everything will be explained. Then we will discuss very important reaction as per as CSIR, UGC net and gate point of view, that's intramolecular Parthenon-Bucci, the detailed mechanism and easy way to learn how to get the product. There is methods. Then the reactions of pi systems, all the reactions related to pi systems we will discuss. Then dipi methane rearrangement. This rearrangement is also very important as per competitive exam point of view. Oxa dipi and aza dipi methane rearrangement, we will discuss them in very detail. So this series of lecture contains about 20 to 25 lectures. So at the end of the series of these lectures, you will become able to find the product of any photochemical reaction very easily. So watch each and every video very carefully so that you become able to get the product easily. So this arrow represents the applied magnetic field, direction of applied magnetic field. Okay. So the spin of this is say plus half, spin of this is say plus half. Overall spin become additive, it become plus 1. Now this plus 1 spin may have 3 orientation in the space. It may be in the same direction as that of the applied field. You can draw it like this. It may be in the same direction as that of the applied field. Then it is called plus 1. It may be in opposite direction than that of the applied field, means in this direction, that is called minus 1. Or third possibility is it may be perpendicular to the direction of the applied field, means in this direction, 0. So we have 3 directions in which that spin may behave in the presence of applied magnetic field. When you apply a magnetic field, the spin may behave in 3 ways, either in the same direction or in the opposite direction or in the perpendicular. So that's why it is called triplet. System crossing ISC. Okay. 2 more transitions are that T1 to S0 by this emitting light, and T1 to S0 by emitting heat. So when it emits heats, that is called the same internal conversion, and when it emits light, in this case, that is called the phosphorescence. The process is known as phosphorescence. So that is abstracted by oxygen. So there are 2 electrons. 1 electron move here, 1 electron move here, and this electron form a bond like this. So this step involves the hydrogen abstraction. Now we get the I. What is I? I is here we get OH, and here we get a radical, and here we get a radical. This is your I. This is intermediate, and this is 1,4 diradical. So I may be carbene, may be nitrine, may be some radical. So here in this reaction, it is 1,4 diradical which is produced. Now this intermediate that give different products, like I can give P1, P2, P3, we just see in the examples. So this intermediate undergo various reactions. If it undergoes 1,4 diradical recombination. Radical recombination. Then this radical, this in radical form of bond here, and we get this product. This is your radical recombination. So whenever there is 1,4 radical, there are chances that they recombine to give the product. Second thing is there is a cleavage of carbon-carbon bond. So just removing these to show the cleavage. So the cleavage of this bond. There are two electrons. One electron move here, this electron move here, get a double bond. This electron move here and this electron move here. So what is the product? Product is like that. We have a OH here and double bond here plus CH2 double bond CH2. This carbon and this carbon, they form CH2 double bond CH2. Because of this bond is, that is cleavage, the cleavage of this bond takes place. Okay, so one species is this, another is this. So the species which is formed here, that undergo tautomerism to produce the final product is like this. So there is your one product, here is your second product, and here is your third product. So in this way we can predict the product formation in any photochemical reaction. So we started with the R and we get three products P. First R changes to R star singlet, changes to R star triplet, then it hydrogen abstraction, after that it immediately changes to I, that is I, 1,4 diradical is I. I may be carbene, nitrene or diradical. So keep in mind these things. Then this I radical that rearrange itself. So rearrangements are of, in the next lecture we will discuss what type of rearrangements are there. So here there is a hydrogen abstraction, there is a cleavage of a bond. Okay, so when there is a hydrogen abstraction you get this product, recombination. When there is a, you can say cleavage of bond, you get these two products. So this is a first example of photochemical reaction, and just compare it with our whole introduction, that how the R that changes to P through various steps. We will undergo hydrogen abstraction from isopropyl. Just draw the isopropyl to H, C, H3 and same here. This is your isopropyl alcohol. Now, hydrogen abstraction, intermolecular hydrogen abstraction, this radical O that will take out the hydrogen from that. It cannot accept sigma non-bonding electron. It cannot take out the pi because pi system is not there. So only option is that it can abstract hydrogen, or you can say the electron transfer from some sigma bond to that this oxygen. Because out of this O and C radical, O is more reactive because electron present in non-bonding of oxygen, they are more reactive. They are always dominating. So pi is going to abstract the proton. From where it will abstract the proton? There are three types of protons. This is A, this is B. All these three and these three are B, and this is your C. From where it will take the where it take abstraction of hydrogen. Now, if you are thinking that OH bond is polar and it will take the hydrogen A, that's wrong. If it will take the hydrogen A, then you will get the same initial products. You can try it. If this hydrogen is shifted here, you will get isopropyl alcohol, and this changes to your acetone. You get the same product. That's why it will not abstract the hydrogen which is present on oxygen. If it will take this hydrogen, then you will get the initial products. So no use. Then option is BC. Now if it abstract B, we get 2 degree radical. If this hydrogen is to be removed, we get 2 degree radical. If this hydrogen is to be removed, we get 1 degree radical. and we know that 2 degree radical is more stable. It means it will abstract 2 degree this C carbon. So there are 2 electrons, one will be abstracted by this and second moves to carbon. So which products are formed? It will changes to dot this is OH, and it is going to change CH3 C, okay, OH radical and CH3. So these 2 intermediates are formed. Now these intermediates are same. You can see these both are same. So what they do, they may be combined. Both are same. So these 2 which are produced, they may be combined.